In Module 10, we jumped around a bit in the textbook as we talked about indefinite and definite integrals. We're going to do the same thing in this module as we cover some indefinite integral problems with substitution from section 6.2 and jump ahead to section 6.5. I believe it's 6.5. Yeah, skip ahead to section 6.5 to look at some of these substitution problems that also require that have upper and lower bounds, so definite integral problems. What we want to look at first in match problem 3 from section 6.2 is the integral of this function raised to the fourth power times 2x minus 3 dx. So again, we want to start by identifying our interior function, which in this case is x squared minus 3x plus 7. So we'll let u equal x squared minus 3x plus 7. So again, the first thing to do is identify a substitution that will hopefully simplify our problem. Now we want to, in step 2, express this problem in terms of u and du. So u, we can just go ahead and swap in for x squared minus 3x plus 7, but then we still have 2x minus 3 dx to somehow get rid of those this variable x and this expression dx. So what we'll do is take the derivative of both sides of our substitution expression. So we have u, and what we want to find is du dx, so the derivative of this function. So this is going to be 2x minus 3. And now what we can do is multiply both sides of this expression by dx. We haven't really talked that much about what exactly dx is, but we can treat it like we would treat a number. If we're dividing by dx on one side, we can multiply both sides by dx, which will lead us to du equals 2x minus 3 dx. So what that means is, in place of this expression, 2x minus 3 dx, we can substitute this expression du because that's exactly equal to the remaining portion that we have in our problem there. So our integral can be rewritten as the integral of u to the fourth power. So just swapping in u for that original function there. And then in place of the remainder of this problem, du. So again, the advantage to the substitution method is now we have just a simple power rule to integrate. So integrating this is as simple as increasing that exponent by 1, dividing by the same amount, and then adding that constant c. So that's step 3, evaluating this new integral, which should be relatively simple at this point. And then in our very last step, express our result in terms of the original variable. So we don't want our result in terms of u. The original problem was in terms of x. So in place of u, we'll substitute x squared minus 3x plus 7 back into the problem. And that gives us our final result.